What's going on, guys? Welcome back to this video. Today we're going to take a practical example of Docker container penetration testing. So this example is found in TryHackMeThe website, and the name is The Great Escape. So basically here we have a scenario where we get access to a website, and from that website we need to find a way to get a shell. So when we find that way to get a shell, we find ourselves in a container, a Docker container. From that point forwards, we need to find the flag and mount the file system or escape. So, alright, so let's get started. Okay, so the first thing, I didn't do the nmap scan because it's pretty obvious that we have two ports open. One on port 80 and the other one on port 22. So the next step I did here is to start exploring the web application. So I went to the web application here. Let's open the main page and give you some tour on the basic functionalities or different functionalities exist on the site. As you can see, the name of the site or the title, Docker Escape. Let's stop the perp. Okay, so we see here we have different functionalities. Here we have courses, we have admin, I have sign up, and then we have login. And of course, if we view the page source, we're not going to find anything. The machine is kind of slow, so I'm going to skip some steps that didn't work with me. Alright, so as you can see, courses, if you click on courses, there is nothing. If you click on admin, we have a login form. The login form, we need to provide username and password. Now, again, there are several methods to work this out, starting with trying basic credentials, passing through SQL injection, or you can also try brute force, but it's not going to work. We have the sign up form. The sign up form doesn't work. Signups are currently disabled to prevent rogue accounts. So as you can see, the basic site, the different functionalities on the site don't do anything. So we turn hits into directory brute force. Okay, so what I did, so this is for the login form. Let me tell you what I did for directory brute force. So I started with, okay, so the first directory brute force attempt was to discover hidden directories. So I started with this command, go buster, and with the main URL, and the word list is big.txt. Also I tried common. As you can see, we received this response. The server returns a status code that matches the provided options. This means that GoBuster couldn't send the probe requests to the web server and received negative status codes, 404. Now, if you try this on /API, so why /API? Let's go back. If you go to robots.txt, which is a pretty basic step if you are exploring and enumerating different directories and files on the website. So we see these entries. We have disallow /API, disallow exif utility, and disallow .back.txt. So these entries are hidden from search engines. So if we take the time to discover every single one of them, so if we go to /API, let's go to /API and show you the page. So it says nothing here, nothing to see here, move along. And if you go to /exif-utility, that's what we receive. And lastly, we have this. So here it's disallowing search engines from indexing any file that ends with .back.txt, disallowing maybe backup files or plain text backup files. Let's first take a look at this one. So this is part of the web application where we can upload files, and the other part is where we can upload files off a URL. We can pull files off a URL. Okay, before dealing with this, let's go back to the directory search. we discovered that we have this directory, right? So we try brute forcing, or we try directory search on this URL, and it didn't work. As you can see, we received 503, an error on the origin server. So this output, coupled with this output, it means that there might be some rate limiting implemented on the web server that prevents us from sending a couple requests simultaneously, whether these requests are sent for the purpose of doing directory search or for the purpose of doing login brute force. So brute forcing directories, or brute forcing passwords, usernames, whatever comes under brute force, it's not going to work on this machine because there is rate limiting implemented as we see here. Let's go back now to this. So we have these upload files, and we have from URLs. Now here you might be telling me, what if we uploaded a reverse shell? Reverse shell wasn't going to work. The only thing that would work is uploading image files, and this one is not going to work. Now from this one, from URL, if you try to submit any URL that ends with a PNG, apparently we need to use PNG, right? Because the server will retrieve the PNG and display the EXIF information about this, or the metadata. So if you submit on this one, as you can see, the connection was refused, and apparently because the image doesn't exist. So we have to provide a valid path so that we get the functionality to work. So this image points, as you can see, this is the URL of this image. Let's try to submit, and we receive the EXIF information about the image. Okay, that's good. Now this is the basic functionality of this. So there is something running the EXIF tool maybe on the input we supply here, the image. So the EXIF command is running. If we try to run something different, let's try to run a remote image. If we are able to display the EXIF information of a remote image, okay, it means we have an SSRF vulnerability, or we can somehow include requests or make a request to remote URLs from the server. Okay, so this could be local remote file inclusion, or SSRF vulnerability. So let me try some remote image. So let's see here. Okay, this one. This is a remote image, as you can see, it exists on this site. If we submit, okay, perp is not running. Submit one more time. As you can see, we have a lag in the response. It means that the machine is not able to make a request to this to retrieve the information about this image, and we get this error. An error occurred, connect timed out, and we get 0 response. If we try something on the local machine maybe, but let's try something that is not an image. Let's make a request to this IP, and we get this: an error occurred, file format couldn't be determined. So it must be an image here for this functionality to work. As you can see, guys, we receive the HTML code, the source code of this page. So while we couldn't get the EXIF information about the image because there's no image, right? We didn't use the functionality here, but we were able to execute or make the endpoint make a request to this IP address. So there is some tool running, okay, or there is some kind of system command that has retrieved the contents or the HTML content. If we try to retrieve something else, like maybe from google.com, are we able to make this request? It looks like it cannot. It doesn't make remote requests for some reason. So there might be, it could be because of firewall. I suppose it's because of firewall. So if you go back and run the request here one more time, and we get an output, the HTML output or the source code of the page. Okay, now this means that there is an SSRF vulnerability, server-side request forgery. Okay, and it is not remote file inclusion, because if it was a remote file inclusion, we would have been able to retrieve any file remotely. But because of the existence of a firewall, we cannot make these requests to remote destinations. We are only able to make requests to to a destination that's local, like this URL. It's not an image file, so we get this error, but at the same time, we are able to retrieve the HTML content of this page. So there is an SSRF vulnerability. We're going to put that in mind. Somehow we're going to take advantage of this later. If you go back, and we have this. So the search engines are not allowed to index any file that ends with .backup.txt as an extension. What if we want to see all of these files? If there is a way to retrieve all of the files that are stored on the web server and at the same time ends with the backup.txt extension. To be able to do that, we're going to have to use a word list. Okay, and as we remember, we cannot do directory search or any sort of brute force because there's a rate limiting, and now we discovered that there is firewall that prevents requests to remote destinations. A side note, this also means that if you try to upload any reversal, it's not going to work because of the firewall. Let's go back here. Now, the goal here is to discover all of the files, okay, with the backup extensions. What I did here, let's go back. All right. So I used Sewell, which is a tool to make a word list. And I used the URL of the page as a source to collect the possible word list. The minimum characters is 4, and the output will be in gescape, great escape.txt. That's my word list that Sewell was able to create. So what I did, I edited the word list to include more words. The words are taken directly from the site. For example, I included courses, I included admin, I included photo, classroom, courses, sign up, login, and also included URLs like exif utility. I include all possible words in this word list. Let me show you the contents of this word list. Not that much, not that many words, as you can see. Some of them were created using the tool, and some of them I created them manually, inspired by the site or from the website. Alright, let's go back. The next step now is to use wfuzz. We want to fuzz for all possible possibilities that point or designates the existence of files that ends with backup extension. So -w great escape, and this is the URL. So basically I made a mistake. I put HTTPS. Let's scroll down. All right, here. So this is the command. -w for defining a word list, and -u for specifying the URL. This is the URL, and the fuzz point is here. So we replace the fuzz point, or we locate the fuzz point, and we put the word fuzz to indicate that we would like to try all the possibilities from the word list at this position. So we have these responses, and the number of characters for every single payload looks like the same except this one. So exif-utility. So what I did, I navigated to exif-utility.backup.txt, and I discovered this page. As you can see, the class is container. This is also another indication that this web server is running inside a container. Now, if you scroll down, we see this API request. API-dev-backup. It's running on port 8080/exif. This looks like a backup API running on the container on port 8080. And it takes a parameter in the name of URL. So if you want to make a request to this API endpoint, we have to take the URL into consideration at the same time with the parameter. We supply the URL as a parameter. Now let's go back here. Remember that we have a local SSRF vulnerability on this site because we were able to, as you can see, retrieve the HTML content of this URL, despite that the input we supplied doesn't conform to the expected format from the web server. So what we need to do here, we need to make a request to this URL instead. Let's copy that and see what might work here. So submit, and we have this internal server error, of course, because we have to supply the URL. So URL equal, let's leave it empty, and we have this response 404. Couldn't find resource for full path. Let's try maybe like this one. Couldn't find the resource, same as before. Okay. Now remember, we want to take advantage of this SSRF vulnerability, but for now we haven't discovered how to do that. So let's now go to Purpose Suite and see how this will play out. So submit. So this is the request. Okay. Now this is the URL parameter. So what we're going to do, we're going to take this one more time. Alright, so what if we try to inject some commands here? So we supply a URL, okay, and then we use semicolon indicating that we want to execute another command. So if this works, it means that there is command injection. So ID, to retrieve the ID of the current user, sent, and we don't forget to intercept the response. Let's see. It doesn't, I think it doesn't work. Let's go back. Let's remove this URL and maybe use an image here. So let's supply the application with the expected format. So because it's an EXIF tool, so basically you're gonna supply an image. A hypothetical image would work. And here we said we're gonna say our add ID, intercept the response. Indeed, as you can see here, guys, we get a format error because the content doesn't even exist on the machine, and we get the output of the command we supplied, ID. So it means we are running a Docker container with the root user. That's a big plus when you want to escape the container and pivot to the file system. Alright, that's good. Now the next step, we want to find a way to get inside this container. So to do that, we have to remember first that we cannot execute any sort of reversal because of the firewall. So what we have to do, we have to enumerate. Okay, let's go back now and supply the URL again. So forward one more time. So here we're gonna say, instead of ID, we're gonna cat the, or we're gonna display the contents of the current working directory. So ls, and put plus for a space dash la. Intercept the response, and we have application. Okay, let's try to find out what's the working directory we are at. So here we supply pwd. So we are /work. Okay, let's now navigate to the root file system. Submit. And here we say cd plus root. And yeah, we don't intercept the response for that. Let's forward this, and then we're gonna check again one more time if we have successfully navigated to /root. pwd. Oh, come on. Sometimes you have to be patient and don't lose hope immediately. And you accept the response /work to cd to /root. So we're gonna find a way. So submit one more time, and here we're gonna say ls plus -la plus /root, display the contents of the root directory. So it worked here. Okay, we have these. So we have dev /node and we have .git. Alright, let's strip the contents of dev -node. So cat root dev -node text. Okay, hey guys, apparently leaving the flag and Docker access on the server is a bad idea, or so the security guys tell me. I've deleted the stuff. Anyways, the password is, this is the password for the user Hydra, and you might be expecting that could work on the SSRF server, but it didn't work. Don't try it. Save your time. Let's go back now. ls-la. Let's try to view that. There is some talk about the flag. Let's submit to perp and accept the requester, because there must be a flag here. Cat plus root dev node.text. Okay, there is no flag indeed. Alright, let's go back. Now there is another thing we saw earlier. Submit, and here ls plus -la plus root. We have this git. So there is a repo, git repo here. So what we can do, we can retrieve the commits done on the repo, and we can use the diff command to be able to retrieve the contents of every commit on that repo. Okay, so I have prepared this to be ready, because apparently it takes time to write all of this. So we're gonna take this, copy it, and immediately we head to the request. So that's my command. So git, as you can see, --git -d directory to retrieve the directory, or to specify the directory we want to retrieve the commits from. It is that /root /.git, and here we specify log, okay, because we want to retrieve the list of the commits. We have these commits: 1, 2, 3, and the author happens to be the same for all of them. So we're interested in retrieving the contents of these commits. So you could be going about retrieving the contents or trying every single one of them, but to save your time, that's why I'm making this video. The commit that contains the contents we are looking after is, or we're looking for, is this one. So to specify this one, we're gonna have to issue a new request, and we're gonna need to take this one, again we use git command, okay, and we specify the repo with --git -dir, and then we specify again the command we want to execute, which is diff, and here we specify the commit. This should retrieve the contents of that commit. Let's see here. Okay, again, as you can see, we retrieved it. I got tired of losing the SSH key all the time, so I set up a way to open the Docker for remote admin. Remember, in the previous videos, we talked about a way to interact with Docker containers remotely. We said that locally, the Docker engine and the Unix sockets take care of that when you want to interact locally with the Dockers. But when you want to interact with the Dockers remotely, outside the machine, you have to run the Docker daemon. So this note means that Docker daemon is up and running on the machine. To do that, or to interact with the Docker daemon, we have to trigger the port or open it somehow. To do that, we have to use port knocking. Port knocking is a way to open a specific port by interacting with a list of ports sequentially. So if we interact with these ports, or if we knock on them, meaning trying to connect to these ports, using this order, we're going to open the port on which the Docker daemon is running, which happens to be 2375 all the time. And we have the flag. This is the flag for the which task? This one, I guess. For D4. No, 76. Let me check. Or it changes every time, I don't know. Yeah, this one. Find the root flag. I guess it's this one, it's the root flag. What about these? Find the hidden flag in the web app. I guess this is the security. We're going to talk about this. So this is the flag for task 3. Now for task 2, the flag can be found by making a request to this endpoint. How do we find out? So basically, the hint saying that you have to, some well-known files may offer some help. Well-known is a directory that hosts SSL certificates. So if you go to well-known, let's copy that and go to .well-known security.txt. You will find the way to access the first flag. So ping this API, meaning navigate to this API with the URL, and you will be able to display the flag. So, or you can use cur. So cur with a head request -i, uppercase I, and we have this flag. Let's get back to things that matter now. So let's perform a port knocking on these ports. So how did I do this? Let's go back here, maybe. Yeah. So I created a very simple script, escape knock.sh. Let me show you the contents of that script. Alright, my machine is refusing to respond. Let's view that with mousepad. So it's a bash script. Inside the script, you will have to connect to these ports in a sequential order, or in order. So bin bash, and then we use telnet to connect to the port to send a request. The first is 42. You follow the same order you saw here. That's the order we have to follow. We put the IP address and we separate them by line, as you can see, to be able to follow the order. The next step is to run the script. When you run the script, you're going to receive these errors because apparently these ports are not open ports on the machine, but they are required to open the hidden port. So we have to somehow knock on these ports, send a probe or a connection attempt. Anyway, we send the connection attempt, and then we conduct an nmap scan, and we see this port open. 2375, which is the regular port a Docker daemon runs on when you want to interact with it remotely. So the next step, immediately we interact with the Docker daemon. So how to interact with the Docker daemon? I've made videos on that, guys. Get back to this. So for now, I'm gonna show you the commands I used. So let's search for daemon. Alright, expose the Docker daemon on port 2375. First, we can grab the version. If you're interested, you can list the contents or list the running containers. Indeed, that's what I did. Docker-h, the IP address, the port, and PS lists the current containers. And we can see every container on the machine. The container that we have been interacting with was this one, the one running on port 80, running a web server on port 80. And we have this, port 8080, the other backup we saw. This container runs this one, the backup endpoint. So that's the responsible container. And with the last one running in SSH, maybe. Okay. So the next step now, interacting with Docker daemon, meaning we want to get a shell. Okay, so to get a shell, again, I talked about this one. So basically we are running or are mounting the complete file system to a directory we control on the container, happens to be /mnt. And here we use -it, meaning we want to interact with the container. We change root to the shell. So basically when we run this, we get a shell as root. Now the next step is to, as you can see, we have mounted the complete file system. Now we go to /root and we retrieve the contents of the last flag. Alright, additional things I have tried is to escape the container using other methods like the capabilities I talked about in the last videos. I couldn't find the capability admin system, so I proceeded to the other method. Let's scroll down and see what's the other method. Okay, the other method is to mount the complete file system in another way. So the first step is to display the current what they call it, the file system. As you can see, we have dev xvda1 and we have the others. So apparently this is the main one here. So we're going to specify this as our target. The next step is to mount it. So we specifically create a directory /temp under /mnt on the container, and then we try to mount this, but we get permission denied for some reason. We are unable to do this. The other thing I try, which is another method to escape container, is to use the namespace. I also explained this in the past videos. Please guys, get back to this. So namespace, I tried to run the mount command using the namespace of the main system process, which happens to be 1, to make it privileged. So this will mount the file system and give a shell, but I got permission denied. I am not upset because I have already mounted the complete file system, but I tried exploring different ways to do that. So if you go now to displaying the contents of the password file, you will see the other users. The other users are Hydra. As you can see, there's a login shell for that user. Now we go to /home and then we find a user called Hydra. Under Hydra we can see there is SSH key. If you want to log into Hydra, guys, on SSH, what you have to do, you have to add your public SSH key into authorized keys. Okay, add it to authorized and log in with the private key, and you'll be able to get a shell as Hydra. So guys, that was it for today. I hope you enjoyed this, and I will see you in the next video.